Hello everyone. Today's topic is on inverse functions. Okay. For inverse functions, guys, it's easy to apply the logic together. Uh, for inverse function, if you have your graph as f of x, it simply means that the inverse function will be f of minus 1x. Together, if your graph was g of x, your inverse function should be g of minus 1x. Together, these things, the negative signs, they represent that you are now talking about the inverse function of your graph. Together, the inverse function happen always on this line. For your graph to be an inverse, it must be always reflected on this line where y is equal to x. In layman's term, it simply means that whatever that happens on y on the original graph will happen on x on the inverse function, and vice versa. What happens on x on the original graph will happen on y on the inverse function. Are we together? For example, let's start with a simple graph. Let's say you have f of x is equal to 2x plus 4. Are we together? I know that this is a straight line graph with a positive gradient. It will go like this. If you're struggling with straight line graphs, I've done lesson number 17 was on cubic. Lesson number 16 was on quadratic functions. Lesson number 15 was on exponential equations. Lesson number 14 was on a hyperbola graph, and lesson number 13 was on linear functions. Please go check if you're struggling with these types of graphs out together. Okay, but if I have an equation like this, I know that my y-intercept will be 4, and I'll calculate my x-intercept, I'll get a -2 all together. But then if the examiner tells me that firstly determine the equation of the inverse of f together, all I know is that I will use f of x to get the inverse of x. How so? I know that for me to have an inverse, I have to reflect the graph of f of x on this line. It simply means that whenever I see y there, I must put x, and then whenever I see x, I must put y, and then my duty is to just isolate y, put everything on the left hand side, and then y on the right hand side together, and then I will have 2y is equal to x minus 4. I've isolated y, I've taken the 4 to the other side, it became negative, and then y is equal to 1 over 2x minus 2 together, and then I can calculate the y-intercept, x-intercept, whatsoever together. But since I have the original graph, I don't have to do that, because I know that everything that happens on y on the original graph will happen on x of the inverse function. How so? The y-intercept of the original graph was 4. Simply means that the x-intercept will be 4 together, and the x-intercept of the original graph was what? Was equal to 2. That means the y-intercept to become a -2 as well. So whenever I draw my graph, it will go like this. These two graphs will meet somewhere. There. Alright, together. If you're not sure about what I just did, they're making the x-intercept of one graph to be the y-intercept of the other. If you're not sure, you can simply find your x-intercepts yourself. X-intercept, I don't care what kind of a graph you're dealing with, y is always 0. Make y 0, solve x, Then I'll take the 2 to the other side, it will be positive. Then x is equal to 4. We have a 4 there as well. Are you together? And then for y-intercept, I don't care what kind of a graph I'm dealing with, x is 0. Take this equation of your inverse, where y is equal to 1 over 2x minus 2. If I make my x to be 0, my y-intercept will be a negative 2. That's what I have there. Are we together? So whatever that happens on x on the original graph will happen on y of the inverse function. Are we together? Simply means that please write this down. The domain of your original graph will be the range of your inverse function. Are we together? And the range of your original graph will become the domain of the inverse function. Please write that down. Okay, now let's continue. Now let's look at a hyperbola. A hyperbola is a graph whereby you have two restrictions. Are we together? The horizontal and the vertical restriction. For me to find the inverse, I know that the horizontal asymptote of the original graph will now become the vertical asymptote of the inverse graph, and the vertical asymptote of the original graph will now become the horizontal asymptote of of my inverse graph. Let's say we have f of x is equal to, let's take 2x minus 1 plus 3. Yeah, doesn't matter, man. Our graph will look like this, ne? I'll have y is equal to 3 as my horizontal asymptote, and x is equal to 1 as my vertical asymptote. Are you together? And my graph will be here, and then and my y-axis will be at 1, and it will be like this. Here we have 1, and then for the x-axis, if we make y 0, okay, let's solve for x-axis. If this is 0, we'll have 2 over x minus 1 plus 3. We have negative 3. Then we have what do we have? We have negative 3x plus 3 is equal to 2. Negative 3x is equal to negative 1. X is 1 over 3. Okay, the x-intercept is 1 over 3. Something I want to indicate clearly. So my asymptote, my horizontal asymptote is that y is equal to 3. My horizontal asymptote is that y is equal to 3, and my vertical asymptote will be at x is equal to 1. Are we together? So for me to draw my inverse graph, my graph will be like this. Are we together? Now the horizontal asymptote will become the vertical asymptote. Are we together? And the vertical asymptote of the original will become the horizontal asymptote of the inverse. I have 1 there. Are you together? And then the x-intercept of the original will become the y-intercept of the inverse, and the y-intercept of the original will become the x-intercept of the inverse. So my graph will be just like this, and another part will be here. Are you together? If you are not sure about this logic, it's fine. You can find your inverse graph, then calculate everything you want to calculate. Are you together? I know that for my f of x, I had 2 over x minus 1 plus 3. For me to calculate my inverse, my inverse, I need to reflect the graph of f of x along this line. Are you together? And then now, whenever I see x, I must put y. Whenever I see y, I must put x. Just like this. Are you together? And all I need to do is to just isolate y. But before I do that, let me bring the 3 to the other side. I'll have x minus 3 is equal to 2 over y minus 1. Are you together? This thing is the same as dividing by 1. I can cross multiply here. I'll have y minus 1 is equal to 2 over x minus 3. Then I'll have y is equal to 2 over x minus 3 plus 1. Are you together? Okay, if we can check, okay, this is my inverse graph, ne? Let me write, I had f of x, my f of x was equal to 2 over x minus 1 plus 3. My inverse graph is equal to 2 over x minus 3 plus 1. Are you together? Initially, my vertical asymptote, it was this one. But now this thing, it's my horizontal asymptote. Are we together? And my horizontal asymptote was 3. Now 3 is my vertical asymptote. Whatever that happens on x of the original graph will happen on y of the inverse function, and vice versa. Whatever that happens on y of the original graph will happen on x of the original graph. Are we together? So finding the equation, you just simply need to interchange x and y and then isolate y, and then you'll get your equation. Are we together? Same applies to all the functions, guys. Same applies to all the functions. Even when you are dealing with exponential graphs, it's simple. If you have a graph like this, okay, let's start with the most simpler one. Y is equal to 2 to the power x. I know that this graph will go like this. And then for the inverse graph, the inverse of the exponential graph, it's a logarithmic function. For the inverse, I'll have the log of x base 2, and that graph will go like this. Right, together. Still has the same features. The original graph is increasing, the inverse graph is also increasing. Still has the same features. Okay, but the y-intercept, it was 1, the x-intercept is 1. The x-axis were the asymptote, the y-axis are the asymptotes. Whatever that happens on x will happen on y. Are we together? So if ever I have a graph like this, maybe y is equal to 2 to the power x minus 4, I know that this graph will have an asymptote there at y is equal to negative 4, and it will go like this. It will pass at negative 3, and here it will pass at 2. out together. This thing simply means that my logarithmic function will look like this. Before I even find the equation, I know how will it look. It will have the vertical restriction at x is equal to -4, and it will have the x-intercept at 3, the y-intercept at 2. My graph will look like this. Before I even find the equation, by just looking at the original graph, I can simply draw the inverse function. Are we together? But let's say because I know they like to ask this one a lot. If you are given an exponential graph, we are told f of x is 2 to the x minus 4. Determine the equation of the inverse function. Yeah, football to determine the equation of f minus 1. Immediately when you see this, it must click into your mind that they are talking about the inverse graph. Are we together? So what will you do to get the inverse function? You will simply reflect the graph of f of x on this line. Simply means whenever you see x, you put y, and whenever you see y, you put x, just like that. Whenever you see y, you put x, whenever you see x, you put y. And now your duty is to isolate x. Are we together? And then you'll have x plus 4 is equal to 2 to the power y. Whenever you're isolating y in simple English, in mathematical English, you're supposed to solve for y. And y is at the exponent. I can't make my bases to be the same. I must introduce logarithms both sides. I must have the log of x plus 4 and the log of 2 to the power y. There's a rule, the exponential rule, that I can bring down the exponent of my index and have something like this, and I'll divide both sides. We divide both sides by log 2. By log 2, this will hambanale. Then I'll have y, which is isolated, is equal to the log of x plus 4. I can just write the 2 here instead of dividing by log 2. I can just write it there. So this will be my equation. All together, we can all see that this number is greater than 1. Simply means that my graph will be increasing. It will be increasing on the right hand side of the asymptote. Please check the video for log graphs as well if you're struggling. And then I have my asymptote. I have x minus 4 for my asymptote. I need to say I'm dealing with logarithms. I need to say x plus 4 is greater than 0. That means x should be greater than a negative 4. Are we together? X cannot be 4. That means this guy is the asymptote. Are we together? If you check on the original graph, the horizontal asymptote was y is equal to 4. But now on my inverse, the vertical asymptote x is equal to 4. My y-intercept was -3. My x-intercept is -3. The x-intercept was +2. Now my y-intercept is a +2. Whatever that happens on y will happen on x, and whatever that happens on y, whatever that happens on x will happen on y. Even with the domain and range, guys, the domain of the original graph would become the range of the inverse graph. For example, in this graph, the domain for f of x, the domain of my function, it was just x element of real numbers, because my graph could go to negative infinity until positive infinity altogether. But here, my range, but now on the graph of my inverse, my range is the one where y is an element of real numbers, because y can go to from negative infinity to positive infinity. It's my graph is not restricted vertically altogether, but now my range, as you can see, my graph is just above the asymptote, so I can simply say y is greater than a negative 4. And then now let's check my domain of the inverse graph. Are you together? The graph is on the right hand side of the asymptote, simply means x is greater than a negative 4. Are you together? Whatever that happens on x of the original graph will happen on y of the inverse function. Are you together? Now let's check the parabola. Let's start with the most impossible one to ask. We have x squared minus 2x, okay, plus 2x minus 8. We have this graph here, now. Let's do this, because you can easily find an inverse graph if you have your graph in this form. Minus x if we have our graph like this, it will be easy for us to find the inverse. Please guys, if ever you're given a quadratic equation, or a quadratic equation as a trinomial, before you find your inverse, please complete your square so that your graph will look like this. It will be easier for you to find the inverse when it looks like this. It will be much more easier. Okay, I know that my graph will look like this. My turning point will be somewhere here at 3 and 4 together, and my y-intercept, whenever I put 0 in space of x, I'll have 9 multiplied by negative 1. Okay, so I'll have negative 9 plus 4, I'll have a negative 5. So my graph will be like this. Excuse my lack of drawing skills. Here I will have a 1 and a 5, and here I'll have a negative 5. I'll have a negative 5 there. Okay, my graph will look like this now, guys. For me to find the inverse, it's still the same logic, guys. Whatever that happens on y will happen on x, and whatever that happens on x will happen on y. Are you together? Firstly, my turning point will be here. The x coordinate will be 4, the y coordinate will be 3. Are you together? And then I will have my graph move like this. Here is 1, and then another part will be like this. We'll have 5 there. Y 0 x-axis. Okay, I have deliberately drawn with 2 different colors. Why? Because I want to show that the inverse graph of a quadratic function must be always restricted. Are you together? You must be told, in this case, Since our graph is symmetrical here, this thing is not a graph foot. Our inverse is symmetrical on the line y is equal to 3. Are you together? So you will be told whether you must draw the inverse of f where y is greater than 3 or where y is less than 3. Are you together? When y is greater than 3, we'll only see the black parts only. But when y is less than 3, we'll only see the green parts only. Are you together? We are not supposed to draw both of them, because when you do that, now this thing is no longer a function. Are you together? To test a function, you always do your vertical line testing. Are you together? For a function, every x value has only one corresponding y value. If one x value has two different y values, then that drawing is not a function. Hence, a circle is not considered as a function. Are you together? So this is how you deal with inverse graphs, guys. Ne? Let's say we're given our f of x. We said it's equal to negative x minus 3 plus 4. For your inverse, guys, always the time, make y to be equal to x. Are you together? And then isolate y. Whenever you see y, you must put x, and whenever you see x, you must put y. It's as simple as that. It's as simple as that. Are you together? And then if I take this bracket to the other side, it will be positive y minus 3 all squared is equal to 4 minus x. Are you together? And then I can take the square root both sides. I'll have y minus 3 is equal to plus or minus the square root of 4 minus x. Whenever I put a square root, guys, whenever you're solving, please don't forget the right hand side should always say plus or minus the square root of x. So my graph will look like this. Either y will be plus 4 minus x plus 3, or y will be minus 4 minus x plus 3. If it's plus, you don't have to indicate the sign. Are you together? So my graph will either look like this or like this. Are you together? So since we have drawn our two graphs, the top part will be the one whereby y is equal to positive 4 minus x plus 3, and the bottom part will be the one which is equal to a negative 4 minus x plus 3. Are we together? That's how we deal with inverse functions, guys. Everything that happens on x happens on y. You just need to interchange the two. I hope this was fruitful, guys. Please stay tuned, wait for more videos, and subscribe to the channel. Thank you.